Secondary oil recovery has become a major part of the oil and gas industry due to its ability to significantly produce additional oil after primary oil recovery methods have taken place. Among the many methods available, one of the most popular secondary recovery techniques used today is the method of water flooding, which is the process of injecting water into a reservoir to increase oil production by means of pressure maintenance. Popularity of the technique grew due to the fact that water is inexpensive, readily available in large quantities, and efficiently raises production while maintaining pressure. When engineers design a water flood for a specific reservoir, there are many factors that come into play. They have to take into account mobility ratio, the number of injector and producer wells, injector well patterns, injection rate, sweep efficiency, and water additives. Our goal is to look at these key factors and optimize a water flood design to add value to a mature field. This can be done by optimizing the injection rates and sweep efficiency, adding polymers to injection water, and maintaining the pressure control of the well. Overall, the entire purpose of applying secondary oil recovery methods to a well is to improve the profit margin of the well. With water flooding being one of the cheapest secondary oil recovery methods available, it can be applied to many different types of reservoirs.
Primary recovery only produces on average about 5 to 30% of the original oil in place within a reservoir. The purpose of the project is to maximize oil production during the secondary recovery phase by optimizing water flooding within a specific reservoir to obtain an additional 10 to 40% of the original oil in place. With an estimated 30.5 billion barrels of proven U.S. oil reserves, on average only 25% is recovered using primary recovery methods, leaving roughly 22.9 billion barrels in the reservoir. Through the application of optimal water flooding techniques, an additional 10 to 40% of the oil can be recovered. The main business objective is to maximize oil recovery while minimizing operating costs. Through a thorough cost analysis, we can determine if the cost of an operation outweighs the profits of production.
The main goal of the project is to fully understand water flooding and all of the parameters affecting it when determining the feasibility of the application. In order to determine the optimal parameters for water flooding and further understand the techniques used, the main effort of the project will be focused on four main variables. These variables are optimal injection rate, sweep efficiency, cost analysis, and water additives. The main project objectives are as follows: determine optimal injection rates, sweep efficiency, cost analysis, and water additives for specific scenarios. Utilize a testing apparatus to further analyze and apply lab-based data. Compare lab results with field data. Utilize a reservoir simulator to analyze and simulate reservoir in order to optimize scenarios. Finalize a report and present an overview of our findings.
The project has many requirements that must be met in order to be deemed successful. Knowledge of the subject at hand is a requirement. Therefore, extended research is necessary in order to successfully complete the project. It must have realistic expectations that must be flexible enough in order to allow adjustments for unexpected results and unforeseeable problems. Financial support is most likely required within the project, along with access to labs and/or equipment to perform experiments and acquire data. There are many constraints that will be encountered during this project. The constraints and limitations that are foreseen at this point in time are a possible lack of money, time restrictions, equipment availability, and limited knowledge of the team for advanced, enhanced oil recovery methods.
As with almost all real-world problems for an engineer, necessary assumptions must be accounted for and identified in order to reach a proper solution. Some of the assumptions made at this point of the project include the following: an ability to obtain lab results which will be comparable and useful in the analysis of the identified conditions, access to LSU's lab facilities and reservoir simulation software, the ability to obtain reservoir field data, the data obtained from testing equipment is accurate, the ability to afford the materials necessary to test the conditions, and the ability to obtain core samples for testing.
The project consists of running a multitude of tests to determine optimal parameters in order to maximize oil production in the secondary recovery phase using water flooding techniques. It should consist of laboratory experiments which require outside equipment that needs to be obtained, financial support, and reservoir simulations. Upon completion, multiple sets of data accumulated over the year needs to be analyzed in order to confidently present the best solution to produce maximum oil production in a cost-efficient manner.
The projected risks of the project are as follows. Our hypothesis is proven wrong and our projected improvements don't add any value to the well. Budget constraints end up minimizing the amount of tests we are capable of running, therefore compromising the accuracy of results due to a shortage of applicable data. Lab data may not be 100% applicable to the real-world situations. Another company developed a better solution than ours, and we wasted time and money researching the subject. In order for this project to be considered a success, the following deliverables should be met. Written presentations analyzing and compiling information gathered from each semester. Data supporting our hypothesis of improving the mature oil field. Cost-effective analysis to show that the company profits from the project, and compilation of all data obtained during research.
The following graphic shows the milestone schedule for the fall. Major dates include the final presentation, the project management plan, and the final budget report. This graphic shows our milestone schedule for the spring. It consists mainly of our lab testing and simulating and includes the project completion date.
The following graphic is a summary of our budget. This includes lab materials, oil samples, rock core samples, lab equipment, field data, and reservoir simulator, totaling up to roughly $600. Since we're in the developmental stages of our project, our budget is subject to some error.
In order to receive approval for this project, certain requirements must be met. The project must be realistic given the constraints listed earlier in the charter. The project must provide a topic that is useful to the study of petroleum engineering. It must also include an obtainable milestone schedule and project management plan that can be followed throughout the entire life of the project.
Paul Cupit is assigned the duty of project manager. The responsibilities include overviewing each step during the project's lifespan, making sure the project stays on track and due dates are met, communicating and coordinating with our supervisor, handling the expenditures, and assigning duties to team members. The authority level is equal to every other member, but the project manager is in charge of keeping the project on the right track.